Hi folks, and welcome back to Math with Captain Rod. I'm making this video here as an introductory video into the inverse of functions. So first part of this here, let's see, what is the test for an equation to be a function? Remember that for a function, every x has to go to one y value. You can't have an x value getting mapped to two or more y values. The test for this is called the vertical line test. If you can draw a vertical line through a graph and it touches two or more times, that graph is not a function. So examples of non-functions, let's see here. Oh, sideways parabola looking things, those fail the vertical line test. Circles or ellipses, things that look like this, fail the vertical line test. Things that look like this, that would fail the vertical line test. All right, what does it mean for a function to be one-to-one? All right, so what that means is that for each y value, there is one and only one x value that goes with it. The quick test for whether a function is one-to-one is called the horizontal line test. If you can draw a horizontal line through a graph of a function and it touches two or more times, then the function is not one-to-one. Some examples of non-one-to-one functions, let's see, parabolas. Okay. These would pass the vertical line test, so you can draw a vertical line anywhere here. It's only going to touch once, but it fails the horizontal line test. Let's see here. This type of thing. Here's a graph of a function that passes the vertical line test but fails the horizontal line test. So this is a function, but it's not one-to-one. All right, now we'll get to the main feature here. The main feature today is about inverse functions. So I started this by writing out, okay, what does an inverse function do? Well, the important thing to realize is if the point AB is on a graph of f of x, then the point BA is on the graph of the inverse of x. I.e., what it does is if you have a function f that maps a to b, then f inverse of x maps b back to a again. I'm going to go through a little graphical example here that kind of demonstrates this. So imagine we've got this graph here of f of x that I just kind of sketched in this pair of lines. And here's a couple important points here. So 1, 2, 3, 0, 4, 5, 6, 7, 1, and then 8, and 1, 2, 3, 4, 5, 6, 7, 8. So these are all points on the graph of f of x. So if I were to graph the inverse of x, it would have to have the point 0, 3, 1, 7, and 8, 8. So I'm going to go ahead and do that now. I'm going to do that in a different color here. Let's use green for the inverse. Green just feels like the color of an inverse here. So, okay, 0, 3, 1, 2, 3 would be here. 1, 7, 1, 1, 2, 3, 4, 5, 6, 7. 8, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Oh, right on that same exact point. Let's go ahead and connect the dots. It looks like this. Now, very important fact of life here. You notice that what we're looking at is a reflection about this line right here. And that's the line y equals x. And this is always true. Anytime you have an inverse of a function, if you graph f against its inverse, it will be a graph reflected about this line y equals x. All right. Next part of this is going to be about determine whether a function is one-to-one, and if it is, find a formula for its inverse. So this is pretty easy stuff here. All right, so I'm going to go ahead first of all and rewrite this. Let's write this y equals 2x plus 8. Now, this is a linear function, slope 2. It's going to pass the horizontal line test, so it is one-to-one. To find a formula for its inverse, you just kind of use the fact of what an inverse does, right? What an inverse does is it basically switches the x and y values. So what we'll do is we will switch the x and y values. And then you just solve for y. First step would be to subtract 8. Then we divide by 2. So what we're going to have is x minus 8 over 2. So this is the inverse function of this. And as an example here real quick, imagine we put 1 into this, right? F of 1 is 10. Now look at what happens if we put 10 into this function. F inverse of 10 is going to be 10 minus 8, which is 2, over 2, which is 1. So again, you see how the point 1, 10 is on a graph of f of x, and the point 10, 1 is on a graph of the inverse of x. So let's do this one right here. All right, this guy. This is a line, slope 1/3. So this is also going to pass the horizontal line test. To find an equation for the inverse, let's write it like this. Y equals 1/3 x plus 2. Again, to find an equation for the inverse, we just switch the x and y values. And then we'll solve for y. So we would subtract 2 and multiply by 3. So we're going to get y equals 3 times x minus 2. And again, what you can do here is, like if I put the point 3 in, we're going to get 3 out. And if you run 3 into this, you'll get 3 out. You can do that with any point you want. If I put 2 here, you'll get 2/3 plus 2. You get a number. Take that number, run it through the inverse, you'll be back to 2 again. So this is how you find the equation for an inverse. You just switch the x and y values and solve for y. Let's take a look at this one. All right, y equals 7 minus x. Again, this is linear, slope -1, so it's going to pass the horizontal line test. We'll just switch the x and y values and solve for y. So why don't we do this? Add y to both sides, subtract x, and there's our inverse. Okay, this guy right here, h of x equals 8. Now that one's worth sketching here. That's a line, but it's constant at y equals 8. And this fails the horizontal line test miserably. So you put a horizontal right on top of that, it touches in an infinite number of places. It's not 1-to-1, so we're not going to bother finding an inverse. All right. When you apply an inverse to itself, what happens is you always get x out of it. And I'm going to go through and kind of demonstrate this, where it says use the composition of inverse properties to determine whether the functions are inverses. So this composition of inverse property, what they mean is this: if we apply f to its inverse, we should get x back again. If we do, they are inverses of one another. If we do not, they are not. So we're going to take a look at f of g of x. And that means to place this in here. So this is going to be 1/2 times minus 2x, which is equal to x. So these are in fact inverses. Ooh, same thing. I think that was supposed to be on the previous page here. Well, it's okay. We'll just work it right here. All right, so we have f of x equals 2x plus 5. G of x equals 1/6 minus 5 over 6. So I'll just work this right here. So f of g of x would mean take this, put it in here. So that's going to be 6 times 1/6 x minus 5 over 6 plus 5. All right, so what are we going to get here? This product is going to be x, and then minus 5, and then plus 5, and then we get x again. So they are in fact inverses. All right, so from here up, inverses. I think what I'll do here is stop this video right here, because again, video 1 here was supposed to be about what are inverses. So let me kind of review that quick. An inverse is a function such that if the point a, b is on its graph, then the inverse maps b back to a again. Or I'm sorry, if the point a, b is on the graph of f, then the point b, a is on the inverse function. So examples, if the point 3, 0 is on a graph of f, then 0, 3 is on its inverse, and so forth. That's the real big thing about inverses. When can you find them? When the function is 1-to-1. See, what happens is if the function is not one-to-one, by the time you find the inverse, you get something that's not a function because it'll fail the vertical line test. And then how do you find them? It's pretty simple. You switch the x and y values, like this function, y equals 2x plus 8. You just switch the x and y values, solve for y. It's typically pretty easy to find an inverse function. Now, it can get a bit more difficult, again, when you get more complex functions, but fundamentally that's how you do that. Switch the x and y's, solve for y. So I think I'll stop that video right there. Have a great day.